Okay, so here we are. We're trying to find the critical numbers first, and using the product rule, we boiled down this function here to get this f prime of x, and your critical numbers are x equals 4 and x equals 1. So here's your number line, and then your number line analysis, we go to the left of 1, and so to the left of 1 you're going to have a negative, and what about this thing here? This is always what? It's always positive, and so the thing's going to be negative times a positive over here, so that's going to be negative. Is that correct? Mm-hmm. And then so we're going like this, and then to the right of this, like if we pick 2 for instance, well then we'd have a positive times a positive. And what about greater than 4? Well, we'd still have a positive times a positive. Is that right?
Is that first one supposed to be a down arrow?
That one's supposed to be a down arrow, you're right. Thank you for catching that. And so based on this, so these are the critical numbers. What kind of extrema do we have here? If we draw the arrows right, the arrows tell us where the extrema are. What kind of extrema do we have here? Okay, you just look at the arrows. So the arrows go like this. You have a minimum, right? So we have a minimum at x equals 1. Do we have a maximum here?
No.
Yeah, no relative maximum. And then what is the value of that? Well, we just plug in f of 1 is equal to 1 times 1 minus 3 cubed. So that's going to be negative 3 cubed. That's going to be negative 27. Is that right? So minimum of negative 27 at x equals 1. All right, so we have increasing, we didn't have to do increasing, decreasing, right? So increasing, so f is increasing on which interval or intervals? Where is f increasing? Here.
Or is it increasing from,
Yeah.
whoa, from 1 to,
Yeah, from 1.
would it be just, from 1 to 4, and then?
Yeah, now the thing about it is, I know Kylie she's really toying with something, and she's really on to something here, because what's happening is you're increasing. We know the thing is 0 right here, mm-hmm. right? But between here and here, it's positive. When I say it, the f prime, I mean. So the thing is going to continue to increase, even though the function stops increasing right at that point. Mm-hmm. But alternatively, it is permissible also, even though this is correct, you can also, and you'll see it sometimes written as 1, 4, union 4, infinity. So either one of these.
Either one correct?
To me, as a matter of technicality, I think this one here is probably logically more correct. But if this one here is logically correct, can you see how this one is also logically correct too?
Yeah.
Because these are true statements in and of themselves. You just have a break in the increasing at 0, but because the thing only stops increasing right at that point, still you can make this first statement. So there's some ambiguity in some of the ways we explain things in calculus. Fortunately or unfortunately. I think it's fortunately, because we can do either one of these ways and still be technically correct. That's a good thought. Okay, so now we have that, and decreasing, we'll say f is decreasing on what intervals? On negative infinity 1. Okay, now for the concavity, what's the next thing we do for the concavity? Take the second derivative. So we have this thing right here. So that's going to be so we can take, like, if we use a product rule, we could say this is going to be 4 times x minus 4 squared, and what's going to be, using the product rule, our first derivative of that? What's our first derivative of this?
8.
8
X minus 4.
times x minus 4. And now we can take the derivative of this guy here. I mean, the original is going to be x minus 1, and what's the derivative of that?
1.
Derivative is 1. So f double prime of x is going to be this times this. So 4 times x minus 4 squared. And then these things multiplied together, plus 8 x minus 4, x minus 1. And then we look for common factors here. What kind of common factors do we see here?
I see 2 or 4.
Yeah, I'm seeing 4, and then this x minus 4, right? And then what do we multiply through by? Well, this x minus 4 here. And then plus, that's going to be 2, right? And then we have x minus 1 left. And then you can just simplify everything in here. See, so you're still going to have your critical number. Let's go ahead and actually have 4, x minus 4. And this one simplifies to, is it 3x? Is that 3x minus 5? No. 3x, that's going to be minus 6, isn't it? So 3x minus 6, and we can factor out another 3 out of there, can't we?
Mm-hmm.
So we'd have like,
12, right?
so that'd be 12, and so we still have x minus 4, and then we have, is that going to be
X minus 2.
x minus 2? So simplifying all this way gives us our potential points of inflection, which are
4 and 2.
4 and 2. Okay, and then I'm going to go ahead and put this number line, I'm going to stack this number line right underneath and put f double prime right underneath, and put this 2 and the 4 here, right here, and I try to proportionalize it just like this. And so what goes here, if we take this function, I guess this would be the simplest form here, to the left of 2 we would have a,
Oh, that'd be a concave up.
yeah, we'd have a negative times a negative, so we'd have that looking thing here. And between 2 and 4 we'd have concave down, and greater than 4 we'd have concave up. And this is what's going to help is the curve sketching. So we have concave up between negative infinity to 2 and 4 to infinity, right? And concave down between 2 and 4. And then, as far as what those points of inflection actually are, they are actually at 2 and 4 because of the change in signs. And then, what is the actual value of the points of inflection? You have to put 2 and 4 back into this, right? So 2, if we put in 2, we get like 2 times 2 minus 4 cubed. What's 2 minus 4? Negative 2. And that's going to be cubed is negative 8. So 2 times negative 8. So we would have, so one of our points of inflection would be 2, negative 16. Is that right? And if we plug in 4, we would get 0, right? And so we'd also have 4, 0. So those would be points of inflection. So that's that. Now the quiz I'm giving you is a lot easier than that. And there's not a whole lot of class time left, but just get started on this. You might finish it too.
I'm not gonna finish this.
No way.